Welcome to the sixth and final lesson in the sixth chapter of the Pearson Geometry video series. The 6.6 lesson is the converse of the 6.5 lesson. Theorem 619 says if the diagonals of a parallelogram are perpendicular, it's a rhombus. Theorem 620 says if a diagonal of a parallelogram bisects two angles of the parallelogram, then it's a rhombus. And 621 says if the diagonals of a parallelogram are congruent, then it's a rectangle. Let's take a look at the diagrams. In the first one, you can see that JKLM is a parallelogram because two sides are marked with one arrow and two sides are marked with two arrows, which means that it has two sets of parallel sides. This figure, however, is also marked with a box showing that it has perpendicular bisectors. By definition, and Theorem 619, that makes it a rhombus. In the second figure, we also have a figure marked as a parallelogram, but this one shows a diagonal bisecting opposite angles. Therefore, by definition in Theorem 620, this is a rhombus. Finally, we have another parallelogram marked with two sets of parallel sides, but it's also marked with congruent diagonals. A parallelogram with congruent diagonals is a rectangle. Okay, let's go back up to the examples. In example 1, which theorem allows us to draw a conclusion? If you guessed Theorem 620, you are correct. Angle Q is bisected by the diagonal. And 620 says if it's bisected, then it's a rhombus. But if you said 619, you would also be correct. Because if we add 58 and 32 and subtract it from 180, we get 90 degrees, which means that diagonals are perpendicular bisectors. So based on Theorem 619, MNPQ is a rhombus. Okay, example 2. What are the values of x and y? We know that this is a rhombus, which means that the diagonals bisect the opposite angles, so these two angles are going to be congruent. So we can set these equal to each other and figure out what x and y are. Go ahead and pause the video and set up your equations and solve for x and y. When you've got your solutions, press play and check your answers. Okay, if we start down here with x, we can say 5x minus 10 is equal to 4x plus 3. We'll subtract 4x from both sides, and that leaves us with 1x. Add 10 to both sides, and x equals 13. So we have our first value. Now let's try the same thing with y. Now I generally put whichever one is bigger on the left side so that I end up with my variable on the left side, just because I'm comfortable with it that way. It really doesn't matter which way you do it. Okay, so we're going to say 5y plus 5 is equal to 65 minus y. I'll add y to both sides, giving me 6y on this side. Subtract 5, which gives me 60. Now I can divide both sides by 6, and y is equal to 10. So I end up with x is equal to 13, and y is equal to 10. See if you can figure out the third example. I'll give you a hint. You're going to use the Pythagorean theorem. Okay, in examples 4, 5, and 6, pause the video and determine whether you can conclusively determine if the parallelogram is a rhombus, a square, or a rectangle. Be prepared to back it up with some kind of fact. Then, when you have your answers, press play and check your work. Number 4 has perpendicular diagonals, which make it a rhombus, and congruent diagonals, which make it a rectangle. So, a rectangular rhombus is a square. Okay, in example 5, the parallelogram has bisected diagonals that are congruent. Therefore, this one's going to be a rectangle. No surprise here because it looks like a rectangle. Just keep in mind that none of these are necessarily drawn to scale. And number 6, let's see, triangle ABD is congruent to triangle CBD by side, angle, side. Okay, so angle ADB is congruent to angle CDB by CPCTC, because we proved that the triangles were congruent. And since we have two opposite pairs of angles being bisected by the diagonal, this is going to be a rhombus. Did you get the right answers? Okay, last one. Let's start out by drawing the parallelogram. This makes it so much easier. We know that we have a parallelogram ABCD. So it doesn't matter where you mark it as long as you go in a row once you do. So A, B, C, and D should be consecutive. So I'm going to start here, A, B, C, and D. Okay, so we know that AC, which is going to be this diagonal right here, is going to be 3W minus 1. And BD, which is going to be this diagonal right here, is going to be 2 times W plus 6. Okay, so if it's a rectangle, and they said what does it have to be for it to be a rectangle, then our two diagonals are going to be congruent, which means that AC is going to be congruent to BD, and 3W minus 1 is going to be equal to 2 times W plus 6. So let's go ahead and set that up. We're going to say 3W minus 1 equals, and then we can go ahead and distribute 2W plus 12. Okay, let's subtract 2W, and we're left with W. Add 1, and we have 13. So, if ABCD is a rectangle, then W must be equal to 13. Okay, we are finally at the end. The very last thing that we're going to do is called a concept map. Now, quadrilaterals, we have gone over several different kinds, and all of them are written down here at the bottom of the page. We are going to fit these into this concept map based on their characteristics. And actually, we can break these up based on the number of sides that are parallel. So we're going to have a group of 1, a group of 2, and a group of 4. Okay, so the first thing we want to figure out is, from this group down here, which of these can stand by itself? And if you picked kite, you are absolutely correct, because a kite has no parallel sides, and it's the only one down here that has no parallel sides. So right here, we're going to put kite. Okay, now we need a pair that go together. Okay, again, if we're basing it on parallel sides, the trapezoid has exactly one set of parallel sides, as does the isosceles trapezoid. The isosceles trapezoid is a special trapezoid. So we can say the big group is trapezoid, and then the smaller group, the more specialized group, would be an isosceles trapezoid. Okay, so we've taken care of this one, and the kite. That leaves us with parallelogram, rectangle, rhombus, and square. So of those 4, which one is the most broad? That would probably be the parallelogram. Okay, we've got that taken care of. Of the remaining 3, which one is the most specific? A square is both a rectangle and a rhombus, so that one is probably going to be the most specific, which means we are left with rectangle and rhombus. And that completes lesson 6.6 and also chapter 6. See ya.